This is ISC 2025 section A. Let's go to first question. First question मा चाहिँ यहाँनिर दिएको छ एउटा सर्किट, यो चाहिँ विटस्टोन ब्रिजबाट आएको अनि अकॉर्डिंग टू क्वेशन यो पोइन्ट र यो पोइन्टमा चाहिँ पोटेन्शियल इज सेम, दैट इज नो करेन्ट इज फ्लोइङ थ्रू 5 ohm. So balanced Wheatstone bridge ho, so we have to find unknown resistance. So we use this one, 10 divided by 25, ratio of the resistance in adjacent arms, 10 divided by x. So 10 gets cancelled, x is 25. So the correct option is C, 25 ohm. The relative permeability of substance X is slightly less than 1 and that of substance Y is slightly more than 1. Then which is the correct option? So we have two substances, X and Y. Relative permeability of X is slightly less than 1. Relative permeability of Y is slightly greater than 1. So which is diamagnetic, ferromagnetic or paramagnetic? So we know relative permittivity when you go 1 plus magnetic susceptibility. यो केसमा पनि 1 plus magnetic susceptibility. अब magnetic susceptibility no diamagnetic को लागि it will be less than 0. Okay, so that means and it will be negative, so mu r will be less than, slightly less than 1. Now chi m for paramagnetic, it will be slightly greater than 0, positive, so mu r yo greater than 0 भने mu r will be 1 plus slightly less greater than 1, so mu r will be greater than 1. So yo paramagnetic and this is diamagnetic, so the correct option is X is dia and Y is para. If kinetic energy of moving electrons is made 4 times, then their de Broglie wavelength, so de Broglie wavelength we know is h divided by 2m kinetic energy under root. So kinetic energy like 4 times बनाए, okay, so नयाँ lambda कति हुन्छ भन्दाखेरि नयाँ lambda will be 4 को 2 बाहिर निस्किहाल्छ, h divided by 2 times 2m k under root. This is my original lambda, so new lambda will be original lambda divided by 2 half. So de Broglie wavelength half, it will become half. Number 4 is student ले connect गरेछ यहाँतिर circuit, so that the wires repel गराउनको लागि यो mn र st लाई repel गर्नको लागि circuit connect गरेछ, तर repel त भएन रहेछ, attract भएछ. So के गर्नु पर्यो repel गर्नको लागि? So let's see student को circuit मा यो प्लस हो, यो नेगेटिभ हो, so current m देखिको n मा फ्लो हुन्छ, यो प्लस हो, यो नेगेटिभ हो, सेकेन्ड मा s देखिको t मा फ्लो हुन्छ. So एउटै डाइरेक्सनमा फ्लो हुँदैछ भने the wires will attract. अब उलाई त repel गराउँछ भने एउटालाई अपोजिट डाइरेक्सनमा फ्लो गराउनु पर्यो. So त्यसको लागि let's say यो सर्किट को यसलाई करेन्टलाई मैले अपोजिट डाइरेक्सनमा फ्लो गराएँ. त्यसको लागि के गर्नु पर्यो? यहाँनिर यसलाई पोजिटिभ बनाउनु पर्यो, माथिल्लोलाई नेगेटिभ बनाउनु पर्यो. सो आई हैव टू रिभर्स द टर्मिनल्स अफ द ब्याट्री. कुन चाहिँको टर्मिनल? E2 को, इदर E2 को और E1 को गर्दाखेरि पनि भयो. E2 लाई पहिलाको जस्तै ओरालोमै राख्यो, E1 लाई यहाँ नेगेटिभ बनाएर पोजिटिभ बनाइदिए उकालो. सो in either case the current are flowing in opposite direction. Now the wire will repel. So reverse the terminals of the battery. Option B. N-type semiconductor is that in which has N-type मा के हुन्छ? Majority holes त हुँदैन, free electrons यो हुन सक्छ, trivalent त p-type मा हो, equal number यो त हुँदैन. So majority of free electrons as charge carriers. अब associated region type मा convex lens made of glass is completely immersed in water, its focal length increases. True. Refractive index of glass with respect to water is greater than that of glass with respect to air. This is false because refractive index is less. So this is false. So association is true, reason is false. Number 7 को पनि association reason type. Diffraction of light is difficult to observe in everyday situations but can be observed in laboratory condition. This is true. It is difficult to observe in everyday. And what is the reason? To produce diffraction of wave, size of an obstacle must be comparable to the wavelength of wave. So जुन चाहिँ obstacle को size हुन्छ त्यो चाहिँ wavelength, light को wavelength सँग comparable हुनु पर्यो. That is in nanometers को orders मा हुनु पर्यो. त्यो त अब everyday life मा त हुने कुरा हैन. So it's possible in laboratory only conditions only. So this is also true and this is the correct explanation of the assertion. So option is number A. Both are true and reason is the correct explanation. Now let's come to B. How does resistance of a semiconductor vary with temperature? So temperature बढ्दाखेरि resistance घट्छ. Okay, negative coefficient, temperature coefficient. Figure 3 below shows an ideal transformer. Explain why current flowing through the secondary coil is greater than that in primary. So secondary current चाहिँ greater छ अरे primary भन्दा y. So ideal transformer हो. Ideal transformer मा हाम्रो यो power input र power output same हुन्छ. Power input भनेको primary voltage, primary current, secondary voltage र secondary current. So यहाँबाट I get secondary current by primary current will be primary voltage by secondary voltage, and this is equal to number of turns in primary by number of turns in secondary. So we can see from the diagram that NP is greater than NS, so NP by NS is greater than 1. NP by NS भनेको IS by IP. So IS by IP is greater than 1, which means IS is greater than IP. So since current is inversely related to number of turns, so if number of turns decreases, current obviously it will increase. State one difference between primary rainbow and secondary rainbow. So primary rainbow र secondary rainbow मा difference, first this will be very bright, this will be faint, and अर्को कुरा primary rainbow मा total internal reflection inside the your raindrops only once. Total internal reflection occurs only once. Secondary rainbow मा TIR occurs twice. Okay, it's twice. And अर्को कुरा चाहिँ के हुन्छ भन्दाखेरि प्राइमेरी मा चाहिँ violet inner edge हुन्छ रेनबोको inner edge मा violet हुन्छ, outer मा चाहिँ red हुन्छ, whereas secondary को चाहिँ VRRV red चाहिँ inner edge हुन्छ, V चाहिँ violet चाहिँ outer edge हुन्छ. So there are, we have to write only one, anyone. Next, name any one phenomenon where moving particles behave like waves. So electron diffraction, electronले पनि diffraction दिएको छ यो division and Germer experiment मा, अनि diffraction the wave ले खाली दिएको छ, so electron is a wave. What is minimum energy of a gamma photon should possess to produce an electron positron pair? So gamma photon ले electron positron pair बनाउनु, that is the pair production. Electron र positron बनाउँदाखेरि rest mass यसको हुन्छ 0.51 mega electron volt, यसको हुन्छ 0.51 mega electron volt rest mass energy. So यो gamma photon यो energy बाटै आएको, so at least कति हुनु पर्यो 0.51 plus 0.51, that is 2 times of 0.51. 1.02 mega electron volt चाहिँ कम्तीमा कम्ती चाहिँ यति हुनु पर्यो pair production हुनुको लागि gamma photon को मा, यो भन्दा कम्ती एनर्जी छ भने भएन. So at least minimum energy of a gamma photon should be 1.02 mega electron volt. In an energy band diagram of a certain material, forbidden band is absent. So you identify this material. Forbidden band is छैन, energy gap is छैन. So that means valence band र conduction band, they are overlapping. So you happens in case of conductors.